Ever pondered what could possibly be the origin of everything we see around us, the stars, the galaxies, and even us? This grand question, my friends, has been at the forefront of human curiosity for millennia. From the earliest civilizations gazing up at the night sky, to the most cutting-edge scientific minds of the 21st century, we've always sought to understand our place in the universe. Where did it all come from? What set the cosmic stage for the breathtaking spectacle of stars and galaxies? These are the questions that have propelled humanity's quest for knowledge, leading to the development of comprehensive theories about our universe's creation. We've peered into the vast reaches of space, delved into the minuscule world of quantum particles, and unraveled the elusive strands of time itself. The answer to this grand question, my friends, lies in the beautiful complexity of the Big Bang theory. Imagine a time, about 13.8 billion years ago, when everything we know was condensed into a singularity, a point of infinite density. This moment, this blink in the cosmic clock, is what we refer to as time equals zero, or t equals sine zero. The universe was not as we know it now. It was an incredibly hot, dense state where all the matter and energy of the cosmos was packed into an infinitesimal dot. This dot was so dense and so hot that the laws of physics as we understand them could not function. At this moment, all four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were unified. They existed not as separate entities, but as one singular force. As the singularity expanded and cooled, these forces began to separate, shaping the universe as we know it. Now it's hard to visualize or even comprehend the intensity and the enormity of this event. But let's try to imagine the unimaginable. Picture an oven, but this is no ordinary oven. This oven is so hot that not even atoms could exist. Everything was a hot, dense soup of particles, constantly colliding and interacting with each other. The concept of space as we understand it did not exist. There were no stars, no galaxies, no planets, no life. There was just this incredibly hot, incredibly dense point. And as for time, time as we understand it began at this moment. There was no before the Big Bang. The singularity didn't exist in space. Rather, space began inside of the singularity. The Big Bang didn't happen at a place. Rather, it happened at a time. And that time was t equals sine zero, the dawn of everything. In the beginning, there was nothing but an infinitely small, infinitely hot, infinitely dense point, and then, bang! So what exactly happened during the Big Bang? This question has been a subject of intense scrutiny and study among scientists for decades. In the very first moments following the Big Bang, our universe was an incredibly hot, dense point, almost infinitely small. This high-energy state is often referred to as a singularity. It was filled with particles and energy in the form of light. But then something extraordinary happened. This singularity began to expand. This wasn't an explosion in the traditional sense, but rather an expansion of space itself. And this expansion happened incredibly quickly. This period of rapid expansion is known as cosmic inflation. During cosmic inflation, the universe expanded exponentially, doubling in size again and again, over and over, in the blink of an eye. With this expansion, the universe also cooled down, as the energy spread out over an increasingly large space. As the universe expanded, it also became less dense. The high-energy particles of the early universe moved apart, making room for the universe as we know it to start taking shape. At first, the universe was nothing but a hot, dense soup of particles. But as it cooled, these particles began to slow down and clump together. And these clumps would eventually form the atoms, stars, and galaxies that make up our universe today. But this process didn't happen overnight. It took hundreds of thousands of years for the first atoms to form, and billions more for the first stars and galaxies to appear. And here's the most mind-boggling part. This expansion isn't over. Even as we speak, the universe is still expanding, driven by a mysterious force we call dark energy. In less than a second, the universe grew from smaller than a single atom to bigger than a galaxy, and it's still expanding today. So next time you gaze up at the night sky, remember, you're not just looking at stars. You're looking at the ongoing story of our universe, a story that began with the Big Bang and continues to unfold even now. As the universe cooled, something magical happened. Imagine a giant cosmic refrigerator slowly dialing down the temperature. As the universe expanded, it also cooled, and this cold expanse became a creative playground for particles. The universe was no longer a seething cauldron of energy. Instead, it became a nursery where the building blocks of matter began to form. In this cosmic nursery, protons and neutrons, the heart of every atom, began to take shape. These particles, also known as nucleons, formed within the first minute after the Big Bang. But they were not stable. These tiny particles were like dancers, swirling and twirling, colliding and combining in a delicate cosmic ballet. As the universe continued to cool, these nucleons began to stabilize. They no longer collided with such intense energy, and they began to form bonds that would last for billions of years. The protons with their positive charge and the neutrons with no charge at all began to form the nucleus of atoms. But what's an atom without its electrons? Electrons with their negative charge were also forming in this cooling universe. Like moths to a flame, they were attracted to the positively charged protons, but they didn't crash into the nucleus. Instead, they settled into orbits around it, creating a cloud of negative charge that balanced the positive charge of the protons. This is the world of quantum physics, where particles behave more like waves on a pond than billiard balls on a table. It's a world of probabilities and uncertainties, where an electron is not in one place but everywhere in its cloud at once. And so, as the universe continued to cool, these protons, neutrons, and electrons danced their cosmic ballet, coming together to form atoms. Hydrogen, helium, and a smidge of lithium were the first to form, the simplest and lightest elements in the universe. And from this primordial soup of particles, the first atoms were born. Their birth marked a significant milestone in the evolution of the universe, setting the stage for the formation of stars, galaxies, and eventually life as we know it. From these atoms, the first stars and galaxies were formed. Let's dive into this cosmic ballet, a dance of creation that has been ongoing for billions of years. You see, gravity, that ever-present unseen force, began to play its part in this grand cosmic drama. It pulled these atoms, these tiny particles of hydrogen and helium, tighter and tighter together. This gathering of atoms wasn't arbitrary or random, but a gradual process driven by the relentless tug of gravity. Imagine a celestial dance where each atomic partner was drawn towards the other, swirling together in an intricate ballet of cosmic proportions. In time, these gatherings became dense and hot, forming what we now know as stars. These stars were not mere spectators in the cosmic drama, but active participants, transforming and creating as they lived. Within the scorching cores of these stars, temperatures and pressures were so intense that atoms began to fuse together, creating heavier elements like carbon, oxygen, and iron. This process, known as nuclear fusion, is akin to the universe's own alchemical laboratory, turning lighter elements into heavier ones. The heart of a star is truly a crucible, a place of creation and transformation. And what of the galaxies? Well, these stars didn't exist in isolation. They clustered together, forming galaxies. These galaxies, majestic and vast, are the grand cities of the cosmos, each one teeming with billions of stars. But stars, like everything in this universe, have a life cycle. They're born, they live, and eventually they die. The death of a star, though, is not an end, but a new beginning. In their explosive deaths, stars scatter their enriched guts across the cosmos, seeding the universe with the elements necessary for new stars, planets, and eventually life. So, in a very real sense, we are all children of the stars, born from the remnants of their spectacular deaths. From the hearts of these first stars, every element necessary for life was forged. We are, quite literally, star stuff. Our existence is a testament to the enduring cycle of cosmic birth, death, and rebirth. So here we are, 13.8 billion years later. We've journeyed through the unfathomable expanses of time, from the dawn of the universe to the present day. We started at the Big Bang, the singular point of infinite density and heat that exploded into existence, setting the stage for everything that was to come. As the universe expanded and cooled, atoms formed, creating the basic building blocks of matter. Gravity then pulled these atoms together to form the first stars and galaxies. These celestial bodies lived and died, seeding the cosmos with the elements necessary for life as we know it. Everything we see, everything we touch, and even we ourselves are made of this stardust. We are a way for the universe to know itself, to explore itself. We are the cosmos made conscious. We are all children of the Big Bang, made of stardust, exploring the cosmos that created us.